สวัสดีครับ In this chapter we will discuss further a property of the magnetic field, that is, the magnetic field can produce the electric field. Okay. So far in the previous lecture we have discussed that the current, when we pass a current in a wire, we can produce the magnetic field. We studied the Biot-Savart's law, which is the mathematical expression that relates the electric field and the geometry of the wire to the magnetic field that produced by the current. We discussed the Ampere's law, which shows us the relation between the magnetic field and the current. Okay. And from definition, the current is a moving charge. It's a charge that passing through an area in a unit of time. Okay. And what causes the charge to move? This is the electric field. Okay. So it means that we may say that the electric field can produce the magnetic field through the moving charge. Okay. Or if we may say that the electric field can produce the magnetic field. Okay. Now, we may expect that when the electric field can produce the magnetic field, can it happen in the opposite direction, that the magnetic field can produce the electric field? And that is the topic of this lecture. We will show that the change of the magnetic field can produce what we call the electromotive force, and this electromotive force will relate it to the electric field, because the electromotive force is we may say that it is a driving force that drives the charge to move in a circuit. And what is the driving force for the charge? It is the electric field. Again, we can say that the magnetic field can produce electric field. And from this relation, the electric field can produce a magnetic field, and the magnetic field can produce the electric field. This is very important in the electromagnetic theory, because in further, after you finish this lecture, you will learn that these two fields can produce each other. Okay. These two fields can produce each other, and this can propagate. Electric field can produce magnetic field, and the magnetic field can produce electric field. Electric field can produce magnetic field, and this propagate. We can have the propagation of this in the free space, and we call this the electromagnetic field. Okay, you will learn later that electric field and magnetic field can propagate through the free space, or even in the matter in the form of electromagnetic field. But before that, it is an interesting question, but we will not discuss this in this lecture. You will learn this later. But I will leave this question in this point, that so far when we discuss that the electric field can produce the magnetic field, the electric field needs the charge, right? Needs the charge because it needs the current to produce the magnetic field. If we are in the free space, there is no charge. It means that it seems like that the electric field cannot produce the magnetic field because there is no charge and there is no current. But for the magnetic field, it can produce the electric field. It's no need what the so-called charge. It is because there is no magnetic charge. We discussed this when we discussed the Gauss law for the magnetic field. Right? So it means that there is no magnetic charge. The magnetic field can produce the electric field directly, but electric field up to this point, the electric field cannot produce the magnetic field directly. It needs charge. You will learn later, and this is very important, that in fact the electric field can produce the magnetic field directly without the charge. Okay, and that is the very important point that we can conclude that the electric field and magnetic field can propagate into the free space in the form of electromagnetic field, electromagnetic wave. Okay, and you will learn that later in the chapter of the electromagnetic wave. But in this lecture, let us discuss how the magnetic field produces